morning. Today we will see several modifiers selected from the modifier list. Some of them will be complex, some of them will be very simple, and we will see which one are really useful. Okay, let's start by making a simple object where we can apply modifiers. An interesting thing that I like to do when I work in 3ds Max is I always like to use edged faces visible so that we will see what happens if we use modifiers with or without enough segments. So for example, first modifier that I will show you is called bend, and to apply bend we need to have several subdivisions, so I will increase first number of segments in my box. Okay, and now I will simply go to the modify tab and I will start by applying bend. And in bend modifier I have to deal with several parameters that are, first of all, the axis that I want to bend. By default this is always set as Z axis, so my vertical axis is the one that is going to be deformed, and you can see that if I change angle as parameter, this is exactly what happens. So my axis that is going to be bent is exactly the Z. I can select the amount by using angle. I can also change the direction by using direction, and I will change from where my bending is happening. And another interesting thing that I can do instead is, by going back to 0 in all my parameters, is I can start changing the axis. So if I select Y axis, this is what happens. So the axis that is with this direction right now is the one that is going to be deformed. And even here I can also change direction so that I will have this completely different result. Or I can choose X axis and I will bend my object along its X axis. And again, I can change both directions as well as angle. Okay? And another interesting aspect of using bend is that you can limit the effect. So let's see what happens if I limit the effect. So what it means, as you may see, if I change my point of view, I can see that from where my pivot point is placed, the entire box is going to be deformed. But if I want, I can enable limit effect, and upper limit basically means that above my pivot point there will be a certain part of my box that won't be deformed, and I can change the distance between the pivot point and the part that is going to be deformed with upper limit. So if I change the angle, you can see which part is actually deformed. And with lower limit, if I have, let's say, my pivot point in the middle of my object, I will do the same thing by going below my pivot point. And why this is interesting? This is interesting because bend is a modifier that, first of all, can be applied not to one object only, but even to a selection of objects, and bend can be also applied multiple times on the same selection. So let's see a couple of examples, like Example number 1. I make, let's say, a box. In this box, what I will do is I will go to the hierarchy tab, I will click the button affect the pivot only, and I will click center to the object, so that now the transformation point has been moved from the base to the middle. And I will apply now bend to show you what happens. So if I bend my z-axis now that the center of transformation is here, the result will be this. So transformation is not more starting from the base, but it is starting from the center. And it makes a lot more sense now to use limit effect, because if I limit a certain distance above my pivot point and a certain distance below my pivot point, this part and above and this part and below won't be deformed, and this is the result that I get. And this is applying bend once, but using in a more meaningful way upper limits or lower limits. Let's see what it means instead applying bend more than once. So what I can do, for example, is this. I can make this box here, I can apply bend once, and I will still keep Z as bending axis, so I will get something like this. But if I want, after applying bend for the first time, I can apply a second bend modifier, simply because this time I want to bend my Y axis, and the result will be this. So basically I am bending something that I have already bent before. And technically I can keep applying bend for additional deformations. I can reapply bend, for example, and change bending axis X. I don't know if it makes any sense. Right now, let's see what happens. Exactly, I can also add this additional deformation to my object. So, last but not least, why it is important that when I apply a modifier like bend, but not only, and we will see other modifiers that have same meaning, same starting point. What is important is that my object needs to have enough segments, because if not, bending transformation is not going to happen. So, if I make a box or whatever other object, but I have not enough segments, so let's say I just make 2 or 3 or 4 segments here and there, what happens when I apply a modifier like bend is that my deformations will be simply terrible. Look. So instead of having a real round and smooth deformation, I will get this sharp, edgy result. That sometimes can be a wanted result, but at least you must understand what happens if you have more or less segments in your starting object. Okay? Last but not least, let's see what happens if I apply bend to more than one object. So, I will simply select a sphere and I will make several instances in 2 dimensions. So I will make instances along the Y and instances along the Z. Then what I do is simply I select all my objects. I don't even need to make a group. And if I apply a modifier like bend, what happens is that all my objects will be deformed, assuming that they are one only object with their pivot point in the middle here, so they will work like that. And again, I can also choose not only to apply bend to multiple objects, at the same time I can also apply bend multiple times to multiple objects. So I can then apply bend again. I want to bend along y-axis, and I will get this final result. If I just deselect everything, I will see this very complex combination of objects that have been deformed by applying twice bend modifier. Okay? So let's move on to another modifier, and I want to show you a modifier that is a family of modifier called FFD modifiers. There are several of them. I will start by quickly creating a sphere, and then I go to Modify tab, I open modifier list, and I find several FFD modifiers. There are 2x2, 3x3, 4x4, box, and cylinder. They all work the same. They have just one small difference that I will show you now. So, if I apply FFD 2x2x2, what I have is I create this kind of cage all around my selection. And what I can do now is, if I open this triangle next to FFD and I select control points, I can move these control points, and they will basically influence the geometry that is inside my FFD cage. And I can select to move one object at a time. I can select more than one object, more than one vertex, sorry, at a time. And as I was saying, the only difference between several FFD modifiers is the number of available control points. So the one that is called FFD 2x2x2 has 2 vertices along the X, along the Y, and along the Z. But if I delete this modifier and I apply the one that is called FFD 3x3x3, this is what I get. I simply get a cage that has more vertices. So now I can select more control points. I have these in the middle. There is actually a row of vertices. There are control points in here. And I have these in the middle. And so on and so on. So this is what FFD modifier you do in general. So the only interesting aspect now is that if you don't want 2x2, 3x3, 4x4, but you want to be more free to select how many control points you want, you can apply this generic FFD box modifier, and by clicking set number of points, you can freely choose how many points you want for length, width, or height. For example, I will use 2, 6, 4, and I will have at the end 2 vertices along the Y 6 along the X, 4 along the Z, and I can create my own customized FFD cage so that I can select all these points and make like a zigzag effect on my geometry. Okay, same thing for FFD cylinder. The only difference would be that I will have radial vertices. So if I apply FFD cylinder and I click set number of points, I will have 6 that are on the top. Then I have radial and I can choose how many, and height. And I will create all of these vertices that I can control by going to control points, and now I have this very complex final cage. Or I go again to set number, radial just 2, maybe more along the radius, height just 2, and I will get this kind of cylinder that will control my sphere. So I can make this very complex object in a few seconds just by applying a modifier called FFD cylinder and by choosing right amount of control points. Okay? So, let's see another interesting modifier. This is just for fun. It is used in general, especially in interior design. It is used, believe it or not, in order to make soft pillows. And this modifier is called melt. What melt does is, as the name says, it simulates an object that is melting. So if you change the material that you want to simulate, or you can also customize it, let's say jelly. If you choose here the amount parameter, you can increase this and you will see that your object basically will melt. If you change the material, the only thing that really changes is the physical model that you are going to simulate. So for example, the glass means that it first melts on the sides and then in the center, while if you use jelly or plastic, you will get the exact opposite effect, where the center will collapse, as you can see, before exterior sides. For example, this is one of the quickest way to create pillows that you can place then on a stool or on a chair, because if instead of using a sphere, I select a box and I increase number of segments and then I apply melt, I will make square pillows. I can use plastic so that the center will collapse, and you will quickly have these not that regular geometry that will quickly simulate a pillow on a chair. But in order to make more organic looking shapes, we can then jump on another modifier that is called TURBOSMOOTH. What it does is very complex but extremely interesting. That is, TURBOSMOOTH subdivides your objects and it blends polygons that have a corner, so technically that has a different normal direction. So what this means, if I have just a simple box, you can see that you have 6 polygons and one polygon is pointing up, one polygon is pointing down, one on the right, one on the left, one on the front, and one on the back. So they have all 6 different normal directions. When I apply TURBOSMOOTH as a modifier, what happens is that, first of all, my 6 polygons will be subdivided into 4 smaller polygons. But also, whenever there is a change into the normal direction, 3ds Max will try smoothing these difference. And TURBOSMOOTH has mainly one extremely important parameter that is called iterations. This parameter shouldn't be higher than 3, because the more I increase iterations, the more subdivisions and the more smoothed my result will be. If I go up to 3, you will see that my box has basically become an egg. And if I go higher than 3, it happens just one interesting thing, that is, I get no additional smoothness, and I start by having only unuseful additional subdivisions, and this will make my file becoming heavier and heavier. If I go in general close to 7 or 8 iterations, I will discover that my computer will freeze. And of course, I won't do this right now. So 3 is in general the best to be set. But by knowing that TURBOSMOOTH works when there are differences in the normal directions, what we can actually do is we can control the way that TURBOSMOOTH works by knowing that if we have big polygons with big angles in between, TURBOSMOOTH will make a very curvy result. But if we do something like this, look, if I increase number of segments, what I am obtaining right now is simply that between this polygon and this polygon here, there is a 90 degrees angle of difference. But this polygon and all those other polygons are coplanar, so the angle in between is 0. So they won't be smoothed together, and if I apply TURBOSMOOTH now, you will see a completely different result. There is, let's say 3. The top, the front, the left, the right, and the bottom of my box are still flat, so they are not rounded, and the roundness has been created only when there is an angle in between my objects. Why this is important? This is important because TURBOSMOOTH at the very beginning may result like a modifier with unpredictable result, but if we know that we can control it by knowing the angle in between polygons, we can instead have the exact result that we want. So for example, and then we will jump to another object, if I make this box and then I apply edit poly, I can start by modifying a couple of things in my subdivisions. So I can scale the distance of these vertices, and then I can extrude these polygons here. I will extrude them once and twice so that I can then use bridge to fill that gap, and then I will also extrude these polygons in order to make legs of this very basic chair. This chair, I mean, it's not a masterpiece of design. I can start moving a little bit my vertices. I can make it more interesting, but it is extremely sharp. Where is the problem? The problem is that if I apply Turbo Smooth immediately, the result will be extremely ugly, and you can check it, because I apply Turbo Smooth, I increase iterations to 3, and I will get these terrible result where I have these extremely round all here, I have these very big arches there, it almost look like a tooth, okay? And this is happening because, I will remove it now, this is happening because I have these very long polygons without interruptions that have 90 degrees angle in between. So what I will do to make it a little bit pretty is I will break the continuity between these polygons. So, for example, I will start by extruding a little bit the end of each leg, so that I have this very tiny little polygon that will be smoothed, and then legs will remain straight. I will, as we have seen in previous episodes, I will also apply a little bit of chamfer to break these edges, so to break these angles, and I am selecting edges, and at the same time I'm holding Control key on my keyboard. I will do this here as well. I will apply quickly chamfer so that I will have these smaller angles between my polygons. And I will finish by using also connect that we have seen. So I will select all these edges, and I will click connect. I just need one edge, loop of edges here, and I will do the same again here. Connect. Perfect. So that I can now select my vertices, and I can quickly move these slightly behind and up. I can also select these middle vertices, both above and below. I will move these vertex down, and maybe, but this is only for aesthetic, I will move these vertices down. So now let's have a look. So at the very beginning it looks more or less like the previous chair, but see how different it will be by applying Turbo Smooth. Because now, with all those small interruptions, by putting iterations to 3, I will have this fine looking chair that looks more precise, more realistic. I can also hide edged faces for a second, just for you to see better how realistic my final chair has become. Okay, let's see one couple of last modifiers in order to start working with 3ds Max, and I set again edged faces. One very interesting modifier is called SUBDIVIDE. Why this is important? This is important because sometimes we make certain things and we lose a quick way to apply modifiers to deform our object. A very basic example is when we use ProBoolean. We make a subtraction, start picking, we pick these, and you will see that because ProBoolean has something called optimization that is always selected, and if you want, you can check it into ProBoolean advanced options, and you can here planar edge removal, you can choose no edge removal. So what you can see now is that, I mean, my object was looking fine, but it has a problem. That is, now I have not a quick way to increase number of segments. And if I increase segments, I have to increase segments of my first box and my second box, and this will take forever. While I can apply a modifier that will be super fast that is called SUBDIVIDE. SUBDIVIDE will quickly create triangular subdivisions into my selection. And if I want, by decreasing size slowly, I can make more subdivisions. Or if I want bigger subdivisions, I can increase it. I said slowly because if you go too fast and this parameter goes quickly to 0, again 3ds Max will crash. Last but not least is, now I can use bend, for example, because I have enough segments, but sometimes it happens that when you work with triangular subdivisions, and especially if you apply then TURBOSMOOTH, you may experience pretty weird results, especially here, where you will see weird wrinkles appearing. So, in general, in combination with SUBDIVIDE and applied after SUBDIVIDE, there is an interesting modifier that is called QUADIFY mesh that will turn all of your subdivisions where it is possible. So you can see that here there are a few triangles, but most of my geometry has been divided into square polygons. That is the optimal setup that 3ds Max should use in order to work with deforming modifiers like, as we said, bend, for example. And even if later on we want to apply TURBOSMOOTH, and we will see that even if I go till 3, look, only where, and let me hide the edged faces, only where you have those triangles, but it is very hard to see, is something that is visible only into the topology, that is the subdivision into smaller polygons. You can see these weird results. So maybe only there I can experience wrinkles. If not, everything else is perfect. So this is a quick list of useful modifiers. There are a lot of them that are useful, but to start working with 3ds Max, those are more than enough. And if you find this video useful or interesting, leave a like. Comment if you have questions or if you have a suggestion for more videos like this, and why not consider to subscribe to my channel for more videos like this. And as usual, have fun. Bye!